Hi friends, this video is on motion of physics, graphical representation of motion. This video is brought to you by COACHINGCARES.IN, designing future by smart education. Under this lesson, we are going to study the graphical representation of the motion. Let us start. Uh, this is the case one we are studying. Under the case one, you can see we'll understand the graphical representation of this velocity time graph. So case one is the uniform velocity we have taken. Under uniform velocity, we taken up the zero acceleration. This is the actual condition under case one. So under case one, we are assuming this graph, we are plotting this graph from this point, and from this point, this graph is along this line, straight line. You just notice this graph. This is the time in x-axis. We have taken up the time on x-axis, and we have taken up the velocity along y-axis. So just note it down. This plotting line, this plotted graph is along straight line. So while studying this in the interval of time, say after 1 hour, if I'm taking this time unit is 1 hour, uh, the displacement, sorry, the velocity is same. I mean that is 3. I just take this kilometer per hour. Then after the same interval of time, after 1 hour, again the velocity is same. At the after 3 hours, velocity is same. So velocity is same. Velocity is the constant. We can say this is the uniform velocity because velocity is constant at each and every interval of time. So now, according to this, acceleration will be change of velocity divided by change in time. Change of velocity is 0, so acceleration will be 0. So this is graph represent the 0 acceleration with the uniform velocity because the velocity is no more change in the velocity after equal interval of time. So that's why this motion is uniform motion, or we can say uniform velocity. Now we'll study case 2. Under case 2, we have taken up the condition uniform motion, but at the uniform velocity. Suppose I plot this graph from this point and it goes straight like this. Yes, the same way. This is time along x-axis, and this is say velocity along y-axis. You note it down this graph. Say after 1 hour, this is 1 kilometer per hour at this point. Then again after 2 hours, it is the value of the velocity is 2. After 3, it is 3. So we can say gradually increment of the velocity, or velocity is varying with the time constantly along this straight line. So that's why this motion is the uniform motion. It shows this is uniform motion by this plotted graph, and uniform velocity, we can say this is the uniform velocity just by analyzing this graph line. It is a uniform velocity. So like this we can interpret the graph, plotted graph in different conditions. In the next slide we'll study case number 3, which is under this we'll study uniform retarded motion, or that is called, the acceleration in this form is called retardation or you can say deceleration, another name of this, or retardation, or you can say negative acceleration. So we are going to study in this negative acceleration from the velocity time graph. I just plot one graph line here. Okay. I'm sorry, this is a straight line. We assume this is a straight line. So in this line, you can assume after interval of time, equal interval of time, after 1 hour, after 2 hour, or after 3 hour, this there is a gradual decrease of the velocity. Y-axis we already assumed velocity, and x-axis it is time. So you just note it down after equal interval of time. This velocity is decreasing equally or gradually it is decreasing. So this velocity is decreasing with respect to the time. So that's why the acceleration we can say is the change of velocity, and it is decreasing gradually. So this acceleration is called a retardation. This is called retardation, or another name is deceleration or negative acceleration it is. So that is the condition of the plotted graph by which we can interpret or we can describe this is a retardation or this is a negative acceleration by just visualizing this graph line or plotted graph. So like this we can easily understand and analyze the plotted graph, velocity time graph. We can interpret the different motion or different types of motion in different conditions. Okay, now we'll study area under VT graph. That is that is called displacement. I mean, suppose this is one plotted line or plotted graph from this line. It is going in a straight line like this. Okay, so this is a plotted graph. This is by the graph we can say this is uniform velocity. We have taken up the first simple case is uniform velocity in this. X-axis we have taken up time, y-axis we have taken up velocity. Okay, and here we have taken up the time. So you just visualize what we say. The plotted graph, when VT graph is there, I mean velocity and time graph is there. So area under the VT graph is called displacement. That is the important note. You can note it down here to remember this. That area is called the displacement of the object in that particular motion. So area under this plotted graph is like this. I mean area under this plotted graph is the this area, this box. So area we can say like under VT curve. We can say area under VT curve, which is we can say this is displacement. And which will be equal to by this graph line. Suppose this is A, this is B, this is C, and this is D. So area will be equal to what? AB into BC, which is nothing but this AB is nothing but the time and BC is nothing but the velocity, or we can say this is V into T. So that is the displacement basically. This is the displacement. So you can assume, I mean, area under the plotted graph, you can see, like, suppose I have this VT graph here, like this. This is the graph line. I have supposed this is a graph line. This is y-axis, this is x-axis. So area under this plotted graph, we can say this is the area under this plotted graph. Always. It can be anything. I mean, suppose I take this again, different line. It is the line. So this area is the plotted area. I mean, under the VT curve, this area is known displacement. So this is very important. I mean, here you have to remember it. So we can calculate by VT graph the area under VT graph is the displacement of the object in that particular motion. Again, the next slide we will study. I mean, the total summary of the whole what we studied. So the conclusion of the PT graph and VT graph. PT graph is nothing but position time graph. VT graph is nothing but velocity time graph. So we studied all the quantities like displacement, distance, then velocity, then speed, average velocity, acceleration, then negative acceleration or retardation, you can say. We studied the area under the VT graph. So now the conclusion of the whole study is number one is slope of PT graph is called velocity. Number two, slope of VT graph is called acceleration. Area under the VT graph or uniform acceleration motion is equal to displacement. So these three things we can get from the plotted graph of motion of these kind of quantities of motion. So that is the conclusion and that is the summary that we have studied and you have to keep in mind while solving the problems or while solving the numericals under this chapter. Now in this slide we'll study distance time graph understanding a little bit. So distance time graph, you can see this y-axis we have taken up the distance. This is y-axis, and this is x-axis we have taken up the time. So you can see this understanding of this distance time graph. The green line shows a fast and steady speed. This line, fast and steady speed. I mean, there is a gradual change in equal interval of time and there is a gradual change in distance. So this is fast because the distance is change in the distance per unit time is very high. So this shows the fast steady speed. And the blue line shows a journey with the stop and a return to the starting position. It is showing increasing, the speed is increasing steady speed it is from this point to this point. Then this is there is a stop from this point to this point. There is no displacement, no distance change in distance from here to here. I mean, this is the stop you can say, or object is on rest. And number three, from this position, motion of this object is again returning to the starting position. So this steady speed it is shown because this is a straight line and gradual change is there along this line. So this is steady speed and return to the start position. This is the study of this graph. And the red graph, you can see this graph. So this red line shows the journey starting 2 seconds later after the two. I mean, if you'll compare other two graph lines, these graph lines are starting from 0, but this graph line is starting from 2. So after 2 seconds, this motion is getting started. Then with this initial acceleration, then deceleration, and then a stop, because this is the acceleration, it is increasing, right? So this then after that there is a deceleration, and again this is a stop from this point. There is no change in distance. This is the interpretation, a little bit understanding of the motion while seeing the plotted graph, distance time graph. So we can understand these points a little bit in a clear way. So I hope you are able to understand everything now. So thank you very much for visiting COACHINGCARES.in. Watch free educational videos, get best quality study materials, study from the best tutors and mentors. Thank you once again.